folks. Clock says 3:01, so let's get this started. Can you hear me in the back? Or should I use them? Okay. Hi!
Hello.
Welcome to the ZFS talk at Ohio Linuxfest. My name's Michael Lucas. I spent 20 years as a professional sysadmin. I've been on Unix since sometime in the late 1980s. You get to be my age and they kind of mix together, whatever year that was, 85, 89, something. I'm the founding member of the Southeast Michigan BSD user group. I go to a lot of places to talk about BSD. The Linux folks were very welcoming though. And nowadays I'm making my living writing technical books. And I'm here because of the ZFS books I wrote with Alan Jude. So what is ZFS? ZFS is a modern, highly featured file system. It has built-in data integrity checking. Comes with automatic snapshots. ZFS was created by Sun. Once Oracle bought Sun, ZFS was forked into OpenZFS. These days, the Oracle Unix / Solaris version of CFS is less fully featured than the open source version. The main open source version is called OpenZFS. And you can find it mainly in Open Solaris derivatives like Illumos. FreeBSD has perhaps the largest open source ZFS deployment. And Canonical recently declared that ZFS was their file system for containers. Had I known Canonical was going to do that, I would have written my ZFS books a little differently. But that's what the industry does to us tech authors. Some ZFS features that I'll mention will see in proprietary RAID controllers, and some of these features have been added on elsewhere. But in ZFS, they're a full integrated whole. And what makes ZFS special? Well, there are a lot of good ideas that we'd like to see in file systems. Things like checksumming and copy on write, proper metadata management. All of these very simple and well understood components can be combined into something extremely powerful. And to demonstrate how that works, Mr. Zack here has volunteered to help me. How are you today, Zack?
I'm great.
Just to be sure, do you have health insurance?
I do.
Okay. So, a very simple things here can be combined, and you can basically make the file system do anything you want. Lead it anywhere. Just very, very simple. Thank you, sir. So. ZFS basically turns boring computer stuff into a very, very powerful way to get a lock on your data. However, it requires changing some things in how you look at file systems. ZFS is not EXT. It is not UFS. It is not FAT. The assumptions that you have when running those file systems will turn around and bite you hard. So, if I say S51K, how many of you get that little bit of nausea and feel unwell? There was a generation of file systems before EXT, before UFS. And S51K is the only one of them I could remember. The original Unix file system, or the Unix file system that predated UFS. And UFS today seems bare bones, stripped down. But at the time it came out, people argued against it because it broke the rules of file systems, and you had to have a built-in integrity checker. What kind of bogusness is this? What do you need all these features for? Are you mad? Well, today, you hear much of the same sort of thing around ZFS. So you have to readjust some of your thinking. One key ZFS feature is copy on write. In a traditional file system, what happens when you want to change a file is the file system identifies the blocks on disk that have to be edited. Pick that block up, make the changes, and write it back in the same spot. If something goes wrong and your server goes belly up when that block is half written, you have data corruption. This is commonly called the RAID 5 write hole, although it can happen with pretty much anything. So, if you've ever suffered from this problem and had a file turn out to be corrupt months or years after the failure, and you find that it is so corrupted for so long that your backups have rotated away. I've seen this happen more than once. The nice thing about copy on write, the file system identifies a block that needs to be changed, copies it into memory, makes the changes, and allocates a new sector on disk. So if something happens, yes, you lose what is not written to disk. Nobody can do anything about that yet. But your old block is still there and the file is not corrupted. So the data on the disk is always coherent. An interesting side effect here is you get free file system snapshots. It's just a matter of accounting what blocks are in use, what were replaced, and so on. Now, ZFS expects access to the disk. It has internal routines to check for disk errors. RAID controllers conceal these errors that ZFS is looking for. So, if you're running ZFS on top of a RAID controller or on top of some sort of disk abstraction layer, you will lose some of the, not all, but some of the integrity checking. You can use a RAID controller in just a bunch of disk mode, but make sure it's actually giving access to the disk and not creating a one disk RAID 0 and inserting itself in the middle there. Now people will talk about ECC memory. ECC is a wonderful thing. I highly encourage you to have it. How many of you use ECC memory in your servers? Okay. Some of ZFS's error checking can duplicate what's in ECC RAM. So, ZFS, according to the ZFS developers, ZFS on a non-ECC system is no worse than a regular file system with ECC. I would still encourage you to use ECC and ZFS together, but it's it is viable. Now, disk redundancy, a lot of this error checking and such requires some sort of metadata, some sort of parity data, and depending on your physical disks, you may have to adjust how you store data. For example, it's very hard on the one disk in your laptop to have a RAID array, or ZFS RAID array. You just have to be aware of that and adjust your installation accordingly. Let's talk about some ZFS terms. The big part of ZFS is the VDEV, the virtual device, which is a group of storage providers. Disks. You have a VDEV of 3 disks or 5 disks or 1 disk. A pool is a group of identical virtual devices. If you start off with a virtual device of 5 disks in a ZFS RAID, and that is a storage pool for you, you can increase the size of that pool by adding a second group of 5 disks. But the virtual devices are all identical within a pool. A data set is a named chunk of data in a pool. That can be something like /var, or root, or a block device that you're handing off to a VMware machine for storage. And you can arrange these data sets any way you want. It is incredibly flexible. One thing to remember on ZFS is the -f flag to any command is important. -f means force. This is the ZFS developer's way of saying, you are about to do something really stupid. Are you sure that you want to do this? And there is a case where you want to do something that might be stupid. Okay, virtual devices. The basic unit of storage in ZFS. All ZFS redundancy comes at the virtual device level. So, if your virtual devices are that group of 5 disks, redundancy is within that group of 5. If your storage pool has 300 groups of 5 disks in it, the redundancy, you have 300 separate internally redundant units. And you can put a ZFS pool on top of anything that is a storage provider. ZFS expects that it will be a raw disk. However, you can use a virtual machine disk image. You can use a FreeBSD stackable storage device. You can use an LLVM device. All of these other things, they are not raw disk. You'll want to make sure you add more error checking. And I'm going to call what's at the bottom a disk, even though it might not be, because it really should be. Pardon me. Is it really 25 minutes? No. Okay, virtual devices and pools. A storage pool of data contains only one type of VDEV. You'll hear the terms this type of VDEV and this type of pool get used interchangeably, even though they're really not. You add virtual devices to pools. If you have your 5-disk VDEV, you add multiples of that. You don't add disks to VDEVs. If you have a group of 5 disks as one virtual device, you don't add a 6th to that device. And there's a few different types of VDEV/pool. The simplest is the stripe, where each disk is its own virtual device and data is just striped across them, much like a RAID 1. This is great for scratch space. It has no redundancy. You lose one disk, the whole thing goes away. And for some computing applications, this makes perfect sense. And this should also look fairly familiar. The mirror. Multiple disks that copy each other. And each disk replicates the content of all the other disks in the pool, or all the other disks in the VDEV. A pool that has multiple mirrors in it is a lot like RAID 10, a stripe of mirrors. This is my favorite for high performance. It's also not terribly efficient with disk space because you're using half of your disk space for redundancy. RAIDZ is where things get a little fun. RAIDZ is like, they call it RAID so that you get an idea of sort of what it does, and they add the Z to tell you this is a completely different thing that happens to be sort of like that. So each VDEV contains multiple disks. The disk integrity is maintained via parity. You can lose one or more disks depending on the type of RAIDZ, and you lose no data. RAIDZ can self-heal because of redundant checksums. Every block of data is checksummed, and the checksum is stored in the parent block, all the way up to the root of the storage tree. So every time you access data, ZFS checks the checksum. And if there's an error, it goes and reconstructs that block from parity data. So you never even know, except you start to get error messages in the log that say, this was a problem and I fixed it. You do all read your log messages every day, don't you? Okay, you are all good, decent people, so I'm sure you do. So, one thing that's a common misconception is you cannot add disks to a RAIDZ or any VDEV. You add a new VDEV. I've more than once seen someone saying that they had trouble expanding their ZFS pool. And I came in to find they have a 10-disk array, which is fine. And they started off with a 6-disk VDEV. They can't add another unit of 6 disks. There are only 4 spaces left. At that point, you either have to add a new disk array so you can get those other 2 disks in, or throw it out and start with 5 disk units. But if you have a storage shelf and you want to use it for ZFS, take the number of slots you have, find a number it divides nicely by, and use multiples of that for your storage. And there are multiple RAIDZ types. RAIDZ 1 requires 3 or more disks, and you can lose 1 disk per VDEV. RAIDZ 2, each VDEV must be 4 or more disks, and you can lose 2 disks of VDEV. So half of your disks could have failed and your data will still be served. At RAIDZ 3, 3 disks per VDEV. RAIDZ 3 is increasingly necessary simply because the size of the disk is quickly outstripping our throughput to the disk. 6 megabit a second sounds really fast, and it was great for a 2 gig disk. Now we have 10 gig disks, and by the end of the week, probably 30 gig, I don't know. They grow faster than I can watch. So, it is possible with both RAIDZ and some traditional RAIDs that you can shuffle data for so long that as one disk fails, or sorry, as you are replacing one failed disk, another disk can fail. How many of you have had that happen? Yeah, look around, it's not uncommon, it sounds ridiculous. It is ridiculous, but it's real. Sorry?
Common cause.
Common cause. Often you have a batch of disks from the same manufacturer at the same time. Terrible things happen. I have a lovely story from a manufacturer on how they traced a rash of disk failures down to one guy in China had a cold. And everything he touched that day failed. So there are people around here who run huge storage arrays. Talk to them about hardware and how not to do it. So, if you've been around ZFS, you've probably heard this rule of twos. It is commonly repeated, and I'm taking the time to mention it because it is bogus for most of us. You will hear that a RAIDZ should have a number of disks equal to a multiple of 2 plus the parity level. So, a RAIDZ should have 2n plus 3 disks in it. This is true if and only if your data is consistently small blocks, with a size that is a multiple of 2. And most of us do not have this data. If you have a 10-disk shelf and you want to use 5 disks, use 5 disks. So all of this flexibility kind of makes you wonder, well, what should you do? Well, the argument of how you should configure your storage has been going on since the beginning of storage, and it will continue long after we're gone. But here are some general guidelines. Don't put more than 9 to 12 disks in a single VDEV. If you have a SAN shelf with 144 disk slots in it, and you do it all as one giant RAIDZ 3, 3 disks out of that fail, and suddenly you're out of redundancy, and you better hope nothing else fails while you're trying to repair those disks. So, 9 to 12 disks per VDEV is a good general purpose rule of thumb. If you are special and you need to do it different and you need to have much larger VDEVs, I will not argue with you. I'd be interested in talking to you in a few years to see how that worked out for you. Some people put the whole OS in one monster pool. I personally like to have the operating system in a 2-disk or 3-disk mirror, and then have the data separate in its own pools. I know people who are running huge databases, and they will even have a pool per table. However, they have entire rooms dedicated to storage. So, what works for your environment? So, what makes RAIDZ different from traditional RAID? ZFS combines a volume manager and a file system. This means when it's rebuilding a failed disk, it only rebuilds the part that actually has data, instead of some implementations that write the entire 6 terabytes to your 6 terabyte disk, even though there's 500 meg on it. Not that I've ever sat through that screaming with rage. Copy and write is another thing that very much makes RAIDZ different than RAID. So how do you actually do this? The command lines show that they have a Sun heritage. They get very long very quickly. But let's see. Start by creating a pool. This pool is called compost. And it has these 5 disk devices in it. These examples are from FreeBSD. You would wind up putting in whatever the operating system you're on, what the device nodes are for your disk. I use GPT labels on my disks because I'm easily confused. So this has created a striped pool. It's called compost. It has these 5 entries and they're all there. Yeah, yippee. Making a mirror is very, very similar. Zpool, create. This mirror is called reflect. It's a mirror device, and it has these 2 members. And the entry for this is very similar. Pool name, VDEV name, and then members of the VDEV. RAIDZ is boringly similar. Pool, create, name, type of RAIDZ, members. And ZFS is meticulously consistent in how it displays information, which if you're writing scripts and such is really nice. So there's no standard for RAID over RAID in an arbitrary way. Some proprietary RAID controllers let you do that, but here I'm creating a pool. It's called that. It's RAIDZ1 and it has these 3 members. And here is the start of the second VDEV with these 3 members.
Is that name the same?
Sorry?
I'm sorry. Were those 2 names the same, or did I misread that? The number.
Well, this is the name. This is the type of VDEV.
Oh, type, okay.
And yes, any pool only has 1 type of virtual device in it. And here, we see where the VDEV name comes in handy. So here's the VDEV with these members, other VDEV with those members. So, this happens a lot. This is the most common error that I see with ZFS, is some variant on this. We've created a pool. It has a RAIDZ VDEV, and it has a mirror VDEV. And not that I've been really tired late at night trying to get the install done and had this happen. And ZFS will ask you, it will tell you that this is invalid. Use -F if you really mean this. Once you do this, there is no going back. You have to throw the pool out and start over. So once a VDEV goes in a pool, it's there. It does not come out. OpenZFS is working on that, but the process of emptying the data from a pool, moving it to disks that will remain and freeing up that VDEV for removal is not, well, let's just say it's not as straightforward as we might hope. So listen to the -F. One time you will want to use -F is when you're reusing a disk. I had a bunch of disks in a pool. I have my desktop has 10 hard drives in it because I was writing a book on ZFS and wanted enough storage to do stupid things. And I would have to use -F to tell it, yes, I really mean to use this disk that is marked as part of this pool, because I'm done with that other pool. So, you can look at a pool with Zpool list, shows all of the pools. Here I have this zroot pool is my operating system, the DB pool is my database. and we can get some general statistics from it. Zpool list minus v lists all of the individual providers in the pool. Let's talk about ZFS integrity for a moment. 3:30, okay. I need to talk a little more quickly. ZFS uses checksums and parity data to heal itself. Everything is hashed. Things that you think shouldn't be hashed are hashed. Because someone discovered that, oh crap, we should have hashed that. ZFS has this process called a scrub, which says walk the data tree and check every checksum. If you have no redundancy in a VDEV, if you're running ZFS on your laptop, you can use the the dataset copies property to let you duplicate data, checksum everything, and have a good version to restore from. Yes, that cuts your storage in half if you keep 2 copies of everything. If you have a spinning hard disk, you probably have like, what, 15 terabytes of storage in your laptop, whatever it is now. I found I could spend the space. Now, how does scrub compare to fsck? How many of us know and love and loathe fsck? How many of us have had to play with FSDB and CLRI? You will play with them. You will adore fsck. So,
yeah, right.
One common criticism of ZFS is that there's no offline integrity checking. Well, that's true. A ZFS scrub does everything fsck does and more. You can choose to take your pool offline to scrub it. It won't really give you any advantages other than maybe disk I/O if there's a, just as if you were shutting down the app. But you can. Many of the complaints about scrub not checking this or checking that, there are some valid things with scrub that they're still developing. However, the same complaints and many more apply to fsck. Now, ZFS pools have properties. These are tunables. You'll use Zpool get or ZFS get and set to view and change them. Some are read-only, some are calculated by the pool characteristics. For example, here's the property on a pool. On the ZRoot pool, the size is 920 gig. You cannot increase the size of your disk by changing the tunable. On the other hand, characteristics and properties like bootfs. What data set do we point at for the root file system? You can change that, which means you can have multiple roots on the same disk and boot to a different one. So you can set commentary of your pool, you can set properties, what have you, with the set command. Last nifty feature on pool, pools retain a history of everything that was done to them. Every zpool command that changes the pool. So, when you're the lead tech, and you come in the morning and the pool is destroyed, and your junior sysadmin says, I don't know what happened. You go in, you import the pool, you look at the history, and it says, oh, what is this zpool destroy command that was run at 7:53 a.m. When you'd been here for 20 minutes? How did that happen? There are times I would have committed murder for this feature on UFS or EXT. Speaking of destroying a pool, The Zpool destroyed. Now, ZFS evolves. In particular, OpenZFS evolves quickly, and their development is very widely distributed. So, original Sun ZFS had version numbers. At version 26, you grew this feature. At version 28, you grew that feature. The final Oracle ZFS version, the final Sun ZFS version was version 28. Oracle isn't doing much for ZFS development now. So OpenZFS has set the version number to 5,000, giving Oracle room to do some of their own improvements. And then they've added this thing called feature flags, where you get all the properties from your pool and grep for feature. Feature names all start with feature, at, and then whatever the feature is. You know, LZ4 compression, enabling transaction groups, etc. And so if you are, I'm a BSD guy. If I give you a bunch of disks from my BSD storage array and say, here, put these in the Linux box, you can actually have your ZFS on Linux installed, check for feature flags, and see if there's anything that these pools have enabled that your ZFS can't handle. Or vice versa. You can pick up ZFS disks and move them to move them to Solaris. Sonos would be a good trick. You can move them to Linux. You can move them to anything that speaks ZFS. Now, a data set. Let's go from the great big storage to the smaller unit. A data set is a named chunk of data. It's a file system. It's a volume, which is a lump of data that you use as a storage backend. It's a block device. It's a snapshot. It's a clone. It's a bookmark. The rule with data sets is use lots of them. All of those properties, all those tunables, you can set on a per data set basis. So here's the beginning of a list of ZFS data sets from one of my FreeBSD machines. I have 5 different root partitions. User is one, user home is another, user ports is another, temp is another, var log, vardb, everything is a data set. You can also look at a smaller portion of the data set tree. Creating data sets is very simple. If you have to add a new one, ZFS create, give the pool name and the path to the data set. I've created var MySQL. The -v lets you create a volume. You can move data sets, ZFS rename. You can destroy data sets. When you destroy data sets, there are 2 important ZFS flags that are consistent across the command. -v is verbose mode. -n is the no-op flag. Combined, they say, tell me what you would do if I took these flags away. And that lets you make sure that you didn't accidentally blow away your user or your root. And data sets can have properties just like the pools. And those properties are inheritable. You can set a property on the root data set and it will propagate down to everything beneath it. To mount and unmount data sets, you use ZFS mount and ZFS unmount. There is a mount point property that lets you change where something gets mounted. I have my old MySQL database. I want to mount it on /mount. Now, some things you have to do to take care of pools because 341. I need to speak faster, sorry. Resilvering is when you rebuild from parity. Resilvering is throttled by your disk I/O, as you would expect. If you have no redundancy, if you have no parity, there is no resilvering. ZFS will tell you, these checksums are bad, this file is bogus. Sorry. But at least you know the file is broken. So, and if you have to replace a disk, remember, not all disks are not all disks with the same label on the box are the same size. You have that 2 terabyte disk, but the new disk is 3 sectors smaller than the old disk. You have a problem. The replacement disks have to be the same size or larger. And adding a VDEV to a pool looks very much like creating the pool in the first place. It's just Zpool add instead of Zpool create. ZFS has a bunch of hardware states, and I'm not going to go through them, but they tell you pretty specifically what went wrong. And you can see these errors propagate up the stack. Here's this pool. It's in a state of degraded, which if you look down, these disk devices don't look right. It looks almost like some jerk yanked hard disks out of his PC just to generate an error. ZFS also has caches, new types of caches. Do you have a write-intensive pool? Maybe you need a really fast disk to cache your writes on so that you can spool them off to a lower speed storage. Maybe you have a really read-intensive disk and you want a really fast small disk to cache the most heavily read data. You find your bottleneck and use it, and treat it. Compression. Compression exchanges CPU time for disk I/O. On most of our systems, disk I/O is the limiting factor, but we have gobs of CPU. Some of you probably have 8-core laptops right now that are mostly idle. You put those to work compressing the data as it goes to disk. The default compression algorithm is LZ4. For certain types of data, look at using gzip9. I had a system with 15 years of telecom call records that were plain text, and gzip9 was much better. ZFS also does deduplication. I'm not going to go into details again because there are more interesting things, but you probably don't need it, and you probably don't want it. There are some people it works for. I have never actually logged into one of those systems. Snapshots. ZFS keeps a record of blocks that used to be in use, but that you still want. So you can snapshot the file system right now. And as you write and make changes, it does internal accounting to say, at the time of the snapshot, this block was the one in use, not that one over here. And so through simple accounting, it tracks what the file system state was at this time. You can go into that. You can roll the file system back to the snapshot. Say, oh, this upgrade was a bad idea. Let's retreat. I've had nights where, again, I would have committed murder for that ability. So, the problem with snapshots, your disk is running out of space. You go in your home directory and you delete all those downloaded ISOs. They're still in use on the snapshots, so it doesn't actually free the space. So, sectors are only freed from disk once no snapshots are using them. And you can roll back the snapshot, the newer data will be destroyed. You can also clone snapshots, which is a way of saying, I want a read-write copy of this snapshot. You snapshot your database. You create a clone of the snapshot. You run the upgrade on the clone. The only disk space it uses is the difference between the new and old data. So you have massive data savings, and you get to test and see if the application works after an upgrade. And when you're done, you throw it away. Boot environments are built on clones and snapshots. You snapshot the root file system before the upgrade. You clone it. You upgrade the clone. You boot the clone. If it fails, you boot the original snapshot. And this takes a huge amount of upgrades can still go bad, but the recovery from the upgrade is so much easier. I forget how many systems I have restored from tape because some commercial Unix vendor that shall remain nameless, AIX, did something horrible in the upgrade procedure. ZFS Send and Receive. Remember, the ZFS tracks the blocks that are in use. You can pick up the file system and send the whole thing to another host. You can pick up the difference between the live file system and the last snapshot and send only those blocks to the other host. If you have large data replication needs, this beats rsync so badly that rsync's mom needs urgent medical attention. Definitely look at ZFS Send and Receive for replication. And okay, 3:48, I have a couple minutes. Questions, please ask them. With a couple caveats, don't ask me about the legality of CDDL and GPL. I am not a lawyer, and I've given up explaining Oracle. I'm not even going to guess. Come talk to me about any number of random topics. If you're interested, on election night, I'm giving a talk on how ham is un-American. And I have a certain legality I need to comply with here. So, dear IRS, bug off. I'm deducting this whole trip. So, and if you want, I'll have books outside in the hall, and I'm also giving away nifty little puzzle pens with 2 balls in them. So you have something to do during that con call. But they'll have to be outside because I'm out of time. So, questions? You let me throw you around. Okay. You get to go first.
Is there a helper utility you prefer to use to manage your snapshots? Or just scripts?
Generally, ZXfer is what I use to help with replication of snapshots. If just local snapshots, scripts. Yes, sir?
So, one of your earlier slides, you were talking about the striped VDEV, striped pools. Although I guess when you're talking, I gather that all pools are striped amongst VDEVs, no matter what you do.
Yes, but a pool that is purely striped has no redundancy.
So you had a little note on there that said copies equals 2 for redundancy.
Yes.
I asked what that does, but I saw it also later in your slide and how that compares to RAIDZ.
That gives you an additional copy of the data. It writes the data twice, so that if it discovers a checksum error, it can restore the data from a good backup.
And does it know to distribute those copies amongst different VDEVs?
Yes. Yes, it does distribute among different VDEVs. If you're using something like disk images, though, they may turn out to be on the same underlying disk. So ZFS does its best to distribute data intelligently. If you trick ZFS, it pretty much sucks to be you then.
So you would say that you RAIDZ Z1 as opposed to striping.
Yeah, I would do RAIDZ Z1 or mirroring for most operations. Because a striped pool, if you lose one disk, the pool is destroyed. You can't recover from that.
The
You can-
exception of copies equals 2, right, in theory?
If you switch on copies equal to, you will recover from the stray cosmic ray or electric spark that flipped a couple bits on the disk.
I see.
You won't recover from the disk releasing the magic smoke. Sir,
Encryption, you never touched on encryption. I know ZFS has internal encryption. or-
ZFS is working on internal encryption.
In that case, what's your opinion on using loops alongside ZFS?
People do things like loopfs. It will obscure some errors. However, it will work better than anything else.
LoopFS?
Loopfs?
No, I said loop, as in encryption, loops encryption.
I'm not familiar with it, so I'm going to abstain from answering. People do put encryption layers under ZFS. In the back, you had a question? Or were you just stretching?
A little bit both, actually. But I saw in my time working with Datasets, a lot of this, was system disks distributed across the WAN. And I saw that you were talking some about doing differencing and sending only changes. Is that in any way suited for that sort of purpose?
Yes, it would be suited for that. I would not put disks in different buildings on the same VDEV or in the same pool. I do know people who replicate their data every 60 seconds across the WAN. And depending on how they do the data, that may work well. Anything with replication and distribution gets very complicated and very individualized very quickly. But people do replicate every 60 seconds and get away with it. Yes, sir.
What are your thoughts on ButterFS and how are you comparing it?
It doesn't.
ButterFS is not there yet. Now, there are things like ButterFS recently had the RAID 5, RAID 6 bug of data corruption. And it would be really easy for me to go, neener, ZFS. But it can happen to anyone. I don't care what your favorite operating system is. At some time, there has been some error that has made you go, oh my God, how did that happen? I am ashamed of my people. ButterFS is not there yet. It may be. I want them to exist for the same reason that as a BSD guy, I want Linux to exist. Competition drives people forward. I really want another widely used SSH server because OpenSSH owns that market. Yes, there's like 3% other servers out there, but no, we need competition. And I really want to give the person who follows me an honest 5 minutes to plug in their laptop and let their magic smoke out. I'll be outside the back door. Please talk to me about what's on that list or anything else. I'm here all weekend. Thank you for your time.